Okay, so the last thing on our list is 2.3, calculating trig functions using a calculator, or that's redundant, or whatever. Finding trig functions, whatever. Okay, so for the first part, or the first little bit here, I'm going to give you an explanation of. We've been kind of using calculators for certain calculations as we go along. Anyway, so today I'll look at the more interesting examples. Here, your calculator only has the sine, the cosine, and the tangent button. Also the sine inverse, cosine inverse, and tan inverse buttons. So we have to rewrite everything in terms of those functions so that we can use those buttons in our calculator. So the first example, and hopefully you've got your notes in front of you here, either on your screen or you print them out, is find the secant of 97.977 degrees. So secant of 97.977 degrees. So you should hopefully recognize this is not one of our standard angles, one of our 0, 30, 45, 60, or 90, or multiples of those angles. Or you just see it has a bunch of decimals in there. In either case, you know that we can't really give an exact answer for this, but we can approximate using our calculator. The problem is we don't have a secant button or a calculator. However, we know that secant and cosine are reciprocals of one another. Again, I always remember it because one starts with S, one starts with C. They're kind of the opposite letters there. As opposed to like secant and sine, the same letter. So we need to rewrite this as its reciprocal using cosine. And it's really easy to do. It's just 1 over the cosine. All right. So that's it. We just put that in our calculator. Really straightforward. We don't need a whole lot of parentheses. We just do 1 divided by cosine, and we type in our angle. Now, when you press that function button on your calculator, it's most likely going to open up the parentheses for you. So you can close that, but other than that, you don't need any additional parentheses. Okay. I don't know why I have an extra 7. I don't know why I wrote that. In my notes I didn't. So I get negative 7.2058. So you'd write some number of digits. Minus plus should tell you how many to write. If we're counting our significant digits, we would have, 1, 2, 3, 4, 5 significant digits. Now, what else do we have on our list? That one's pretty straightforward, just using that one reciprocal relation. I've got a couple more examples for you here. Next on our list is using the inverse function. And sometimes that's straightforward, sometimes it's not. We'll start off with our kind of straightforward. So you can find, going back where you just were, you can find sine, cosine, and tangent of an angle. You're just plugging that into your calculator right away. Secant, like we just did, cosecant and cotangent, you have to take the inverse function. Secant, you would have to take 1 divided by the cosine, et cetera, et cetera. But they'll all follow that technique. Now, inverse functions, when we have to use those, your example will look something like this. our angle theta, when we're given that sine of theta is equal to some number here, 0.96770915. So the difference in this type of problem, we're asked to find the angle. We're given sine of that unknown angle, of that variable. So this is where we're going to have to take our inverse function. We went through this once before. We're just adding one little step today. Since we've talked about reference angles now, we can talk about this in terms of reference angles. So first off, just the straightforward part. I take my inverse function. I get that theta is sine inverse this is 0.9670915. Right? So plug it in your calculator, nothing to it. I type in there sine inverse. Most calculators have there's my sine button right there. Most calculators are going to have right above it your inverse function. So in that blue right there, I've got my sine inverse. So I hit second sine, I get that sine inverse function. And that's it. I press enter. It's a syntax error, so I made a mistake. Okay. Oh, I put in 2 decimals. So I do it correctly this time, and I get my angle 75.39999.534. Now, when I look this problem up in your textbook, it says find theta if theta is between 0 and 90 degrees, which is what we found here. In your notes, you notice I don't have that stipulation there. I don't say that theta has to be between 0 and 90 degrees. So what I want you to do is find a couple more angles. We could find a ton of angles that have this, that satisfy this, that cause this to be true. Not only 75.3999534, but any number of angles. So I guess what we could do, we could limit ourselves to just angles between 0 and 360 degrees. Let's say we've got that limitation at least. If you didn't have some kind of limitation, so now I've added this specification that it has to be between 0 and 360 degrees. If I didn't do that, I could come up with an infinite number of solutions for this, right? I could keep on adding 360 degrees to this and getting another angle that satisfies this function. But the only one I want to look at is if there's one other angle between 0 and 360 degrees that satisfies this function, or satisfies this equation, and that's the one I want to look at. How do I find that? Well, I'm going to use reference angles. We just had a section on reference angles. After watching these out of orders, maybe you didn't watch that, so it's going to be pretty confusing. Hopefully you've watched the section on reference angles. Okay. So our angle, 75.399534 degrees. That's about right there. Okay. What other angles have this reference angle? Well, actually, a lot of angles. This one has a reference angle of 75.3999534. This one has an angle 75.3999534. 99534. And this one, oops. Right, so we've got 4 total angles there that have reference angles of 75.39934. So the question is, how do I know which one of these actually satisfy my equation? It's simple. It's simple if you know. It's like everything else is simple if you know it. We're going to do it based off the sign of this. This is a, and when I say sign, I'm talking about the sign plus or minus. This is a positive value. This is saying the sine of my angle is a positive 0.967. So in the initial equation we were given, we had sine is equal to a positive. And my question is, where over here is sine positive? Well, what is sine? Sine of any angle is y over r. We know r is always positive. The only way we can get a positive result from this is if this is also positive. We got positive divided by positive. That would give us a positive. So in order for this to be positive, both y and r have to be positive. Since r is always positive, we just have to look where y is positive. So that's what this tells me. When this is positive, it tells me y has to be positive. I know I've said it before, but I'll probably say this all semester. R is always positive. So we can really just disregard that in all of our analysis of this. Anytime we're doing this analysis, the only thing we're really looking at is the other variables, x and y. Okay? So in order to get positive here, since sine is equal to y over r, we have to have a positive y. So then the question becomes much easier. Where is y positive? Where is y positive? Is y positive down here? In fact, it can't be this one. Is y positive down here? No. It can't be this. Up here, y is positive. Up here, y is positive. So this is the one that's going to satisfy this angle right here. Has a reference angle of 75.39534. And the sine of that function is going to be positive. So that's the one we want. The question is, what angle has that as its reference? Well, that's this angle right here. What is that angle? It has a reference value of 75.39534, meaning from right here, which is what, is 180 degrees? Oops. If we go back 75.3954, that will give us our angle. So that's how we determine it. It's just 180 minus our reference angle. And again, that's something I calculate really easily. And I get 172.600466. Okay. Now, if you want to check yourself, you know, our original equation was sine of that angle has to be this positive 0.967, blah, blah, blah. So is this angle we just got, is that going to do it for us? Well, let's see. What happens when I take the sine of that angle? Sine, and you can do this in the second answer. Most calculators have that answer button. So that's taking the sine of that angle I just came up with at 172. So I take the sine of that angle, what do I get? I get something wrong. What the heck? What have I done? $180 minus 75 is not 172. Right, that's like 112, I think. It's 104. Okay, so apparently that's when we check our work. Now when I take the sine of that answer, let's see what happens. There we go. Now 0.96770.712. That's not exactly what we started with. Like, we had 915, this gave us 712. That is because of inaccuracies in our measurement. And we talked about this. Our significant digits here, we've been carrying those through the problem, but we've lost, we lose some when we perform these calculations. We lose some precision. Either that or I have a typo somewhere. But last time I did this, I also got something accurate out to about here. So that's just due to a significant digit issue. Other than that, this should satisfy. So we have the answer we originally came up with. Theta is the 75.39995534. And we have we found our reference angle that was in the quadrant 2 that gave us that the angle that had this reference angle was 104.60046. That one also satisfies our question. And you could do this, any of these problems, you can do all this extra work to find related angles. These problems in this section are very clear for the most part. They say find the angle between 0 and 90 degrees. So that first part is all you're looking for the majority of these problems. In reality, you need to be aware of the power of these reference angles because we will do problems that want this extra step as well. So the first thing you got to master is this first step, just finding, being able to take your inverse function. But you need to work towards this ability of once you find that angle, you need to see what reference angles would give you that same result. Well, actually, you take this angle, that is your reference angle. Now let's see which one of these you can actually use to satisfy your function. All right, so we got one more like this. Where we're doing both of these ideas. We're using the reciprocal, reciprocals, and we're going to have to use our inverse function. So the example is find our angle given cotangent of theta is equal to negative 1.2575516. Now, again, we don't have a cotangent button. We're going to have to use our reciprocals to write this as tangent. You have to do this step first. You can try to do the other way. You could try to take the inverse cotangent for both sides. But go ahead and try it. You're going to run into trouble. I've got a little footnote about what's going to happen. You can try it though, see what happens. So we want to, just like these other ones, or just like the very first example we did today, I want to rewrite this using my reciprocal. Okay, so this would be tangent of theta is 1 over the cotangent of theta. And what is the cotangent of theta? It's this number here, negative 1.257516. So that's our first step. Okay, so I've got it like that. And I just took out that intermediate step. So now that we've gotten that, then we use the tan inverse button on our calculator. Okay? Let's see how we do here. And so we get theta is equal to negative 38.492369 degrees. So that may trouble some of y'all, that negative sign. And that's understandable. It kind of troubles me a little. Our textbook normally specifies that they want theta between 0 and 90 degrees, right? Well, that's not between 0 and 90 degrees. That's a negative angle, right? It's less than 0. So that, obviously, that's not going to work here for this. If we ask for an angle between 0 and 360 degrees, we can find that. Okay? So there's our angle, negative 38.4923699 degrees. Okay? Now, can I find a corresponding angle between 0 and 360? You bet. That angle right there. They both have the same terminal side. Now, what is that angle? It's 360 minus that 38 degrees. So our new angle, the one that's actually going to work, that's going to satisfy our condition here, is just 360 minus that 38.496 or 49236. Okay. And I get my answer 32.5076301. So now I've got one angle between 0 and 360 that satisfies this. Okay. However, just like in the last problem, if we wanted to keep going with this, there is another angle that satisfies this this function. Now, what is it going to do? What is it going to be? We know it's going to have a reference angle of 38.4923699. Okay, so it could be right here. In fact, I'm going to write these a lot smaller from now. I'm just going to write just a couple of decimal places just to make this. When I do my calculations, I'm still going to use the full shebang there. Okay, so we've got all these possibilities, all these possible reference angles there of 38 or 49 degrees. We already know this one. That one's good. That's what our calculator gave us. Now, our thing said that cotangent is negative. When we started off, going back to the very beginning here, we have cotangent is negative. So we have to do that kind of sign analysis. Cotangent is what? It's x over y. Where could that be negative? It could be negative right here. Consider any point on this terminal side there. You pick some point there. What does it have? It has a positive x value and a negative y value. So that would be a positive divided by negative is negative. So that gives us the negative function value. Okay. Cotangent is x over y. We just saw that x over y is negative in this quadrant. Where else is it negative? Is it negative here? Or let's look at some point. If we chose some point on our terminal side, it has a negative x value, right? Negative, this is on this side. It also has a negative y value, since this one's below the x-axis. So my question is a negative divided by negative, is that positive? Is that negative? Well, negative divided by negative is positive. It doesn't satisfy our rule. That function there, cotangent, has to give us a negative when we take our x and divide it by our y. But we see in this case, a negative divided by a negative is not going to work for us. That gives us the positive. So this quadrant is out. We go up next on our list. We've got quadrant 2 again. In quadrant 2, our x's are negative, and our y values are positive. And that's gonna do it for us. We take our x value, which is negative. We divide it by our y value, which is positive. And that gives us a negative. So in quadrant 2, cotangent is negative. So that would also satisfy our function. Okay, so it's going to be quadrant 2. This one's going to work out for us. I'm going to clean up my graph a little. Okay. Too much stuff going on that graph. Eh? So we had a reference angle of 38.49, right? Yeah. So the question is, what angle has that reference angle? Well, it's 180 minus that 38.49. I need more room to do this. Since I'm actually about to perform this calculation, I'm going to go ahead and write down all my digits there. So it's 492.3699, and that when I do 180 minus that will give me my other angle that satisfies this equation. So I get 141.5076301. And that is our second angle that satisfies this equation. And you should check this. You should check this to see if it works. It's going to be kind of messy because we can't check it right from here. We can't really find the cotangent right away. Oh, I guess we could. We actually could do this really easily. What is cotangent? It's 1 over the tangent, right? So when I put 1 over the tangent of our angle into my calculator, will that give me negative 1.2575516? Well, let's try it with our answer here, the 141. Okay, so I'll do 1 divided by tangent 141.5076301. Okay, so 1 divided by that tangent, let's see what we get. Fingers crossed. There it is, 1.257516. Beautiful. Just what we wanted there. So, again, this first step, focus on that, make sure you can master that, and then go back, and after you've done a few problems, go back and see if you can find the other angles. Find that second angle that satisfies your equation. And it's always going to be one of the 4 angles that has that reference angle that we came up with. So just draw those angles and then test each quadrant until you get something that works. So I guess I should state this again. This is 180 degrees. Right? This is 360 degrees. So a lot of times you're going to be taking 180 and subtracting your reference angle to get your actual angle here. This one right here. If we had been down here in this quadrant, what would I do? I would have taken 180 and added my reference angle to it. So it would have been 180 plus 38. If it was over here, well, we actually did that one. We took 360, subtracted our reference angle, and that gave us our very first result, 321. And of course, if it's up here, it's super easy. It's just our reference angle. 38. So I know there was a lot of talk just to go over 3 problems, but I just want to, those are, I mean, as hard as these can get. So if you can do those, you should be going. So that's it. If you made it this far, thank you for watching, and I'll see you next time.